Good afternoon to all of us. At this time, let me thank you for the willingness of Mr. Humasak Tommy Argos Simanjuntak and Mrs. Parmonangan Tugatorop as our examiner, and especially to Mrs. Junita Amalia as our supervisor, so we can conduct this final project seminar. We are from TA3 Group, and our final project title is Classification Model of Fake News using Bidirectional LSTM and Word2vec as Vectorization. Chapter 1. This is the following parts that will be described in Chapter 1. The first is research background. The distribution of information through online media is done not only by well-known news sites, but also can be done by all internet users without going through any checks. Some information that distributed individually or in groups cannot be justified, and this problem reached 1,000 of people. Based on the research background, we want to build a classification model that help to classify a news as factual news or fake news. To create the classification model, we use Word2vec as vectorization and bidirectional LSTM to classify the news. Next is research question. There are two research questions in our final project. The first is how does the use of Word2vec embedding size and window size parameters affect the news classification model, and the second is how does the use of different LSTM unit affect the news classification model. Next is the research purpose. There are two research purposes in our final project. The first is to determine the impact of Word2vec's embedding size and window size parameter on the news classification model, and the second is to determine the effect of applying different LSTM unit on the classification model. Next, research scope. Variables that we use in this research are title, content, and label. And then there is two models to be trained. The first is classification model for title. The second is classification model for content. And then there are three parameters that will be used to see the effect on classification model. The first parameter is embedding size, the second is window size, and the third is by LSTM unit. And then there are 5 evaluation metrics that will be used to measure our model. The first is accuracy, the second is recall, the third is F1 score, the first is precision, and the last is computational time. Chapter 2. This is the following part that will be described in Chapter 2. First is preprocessing analysis. Part of preprocessing analysis is data collection. Data collection is used to collect the data from a table. This is the first dataset and this is the second dataset. Next, data reduction. Data reduction is used to reduce the column that is not required in this research. A URL column for the first dataset and a name column for the second dataset. Next, data cleaning. Data cleaning is used to clean the data from null data. In this table, we can see the result of data cleaning process. Next, data transformation. Data transformation is only implemented for dataset 2 or the second dataset because the second dataset has a string label, so the string label must be transformed into the binary label. Next, data integration. Data integration is used to integrate two dataset into one dataset. In this part, we can see the result of remove duplicates after data integration is implemented. Next, punctuation and number removal. This part is required because punctuation and number don't affect the result, so punctuation and number will be removed from the data. Next, scaffolding. Scaffolding is required because there are several words that have the same meaning but are written differently, so the data will be transformed into the lower letter. Next, regular tokenization. In this part, we will transform the sentence into a token because the vectorization step need input in form of token. Next, word construction. This part is required to change the abbreviated word in English into its original form, so it will generate meaningful tokens. Next, URL removal. This part is required to remove URL from the data, so it will generate meaningful tokens. Next, stopword removal. Stopword removal is required to get the core information of the news. To get the core information, any word like conjunction, personal pronoun, designative pronoun, and etc. Will be deleted from the data. Next, lemmatization. Lemmatization is required to convert a word without changing the meaning of the sentence. Lemmatization is happen if a word in the dataset is registered in the WordNet, so the word will be transformed into basic form, and if unregistered, the word will be untransformed.
The next is Word2vec analysis. Word embedding is process to converting word into a vector. Why do we need them? In general, machine learning algorithm and deep learning are difficult to analyze data input formed in string or text, so the input data must be formed in vector or number. In this research, we using CBOE architecture to vectorize the news data, where CBOE will predicting the target word probability based on context word around the target word. And this is all the parameter will be used in CBOE architecture. The first is embedding size. This is for size dimension to vectorize the news data. The second is window size. This is a space or distance between target and context word. The third is min count, to count minimum word when training the model vectorized data. The fourth is worker, to speed up the process while training model. And the fifth is iter. This is a looping process while training the model vectorized data. And the sixth is SG, to define the architecture will be used in this vectorized work. And this is the output.
Next, LSTM analysis. LSTM is made up of multiple interrelated components, including the first is forget gate. During iteration process at the same gate, each input information will be selected to determine which will be stored or rejected in the memory cell. The second is input gate. The input gate regulates the amount of input activation that enter the memory cell. The third, output gate. The output gate is responsible for regulating the flow of output from cell activation across the network. The fourth is memory cell. Memory cells serve as information transmission conduit to the rest of sequence change. BLSTM use a forward layer to learn future information and backward layer to learn previous knowledge to process input sequentially in two directions. Next, classification model. The construct model is made up of multiple levels. The embedding layers is the initial layer of the layer. The drop-up layer is the second layer. The BLSTM layer is the third layer, and the last layer is the dense layer. On TensorFlow framework, all of the layers are from Keras library, with a value 64, 128, and 256 unit parameter. In BLSTM is utilized as experiment. The unit means dimension of inner cell in LSTM, because in the LSTM, the dimension of inner cell, output max, hidden state should have the same dimension, therefore output dimension should be unit length as well. Next, evaluation. The following is review of the model that was used. The first is accuracy, percentage of data that was correctly classified. The second is recall, which is the proportion accurately positive, forecast to overall positive data. The third is precision, which is defined of the ratio correctly positive, forecast to overall positive project result. The fourth is F1 score, which is the average of recall and precision result. The fifth is computational time, which is referred to how long it takes a model to categorize or classify data.
Next is chapter 3. In this chapter, we will discuss about general design model and experimental design. This is the model architecture design. The first is fake news, will be enter the preprocessing stage, and the output is list of token. And this output will be enter the Word2vec CBOE stage, and the output is number of vocabulary, and enter the encode stage, and the output is vector and indicates data. In this result will be enter the main classification model using 4 layers. The first is embedding layers, the second is dropout layers, the third is BLSTM layers, and the fourth is dense layers. And after training the model, the result will be evaluated using confusion matrix, where the metric evaluation will be used is accuracy, recall, precision, F1 score, and computational time. The next is experimental design for title data. In this experiment, we built 3 models for classifying the news using different parameters for the embedding size and window size. For the embedding size, we use 100, 200, and 300 for embedding size, and for title data, we using 1, 2, and 3 for window size. And the result of this model will be saved as a Word2vec model, and then enter the classifying using different unit of BLSTM. In this stage, we using 64, 128, and 256 unit of BLSTM. and then the result will be evaluated using a conversion matrix. The next is experimental design for content data. In this experiment, we built a tree model for classifying news, and we use embedding size same as the title data. This model we using 5, 7, and 9 for Windows size. And for the unit of LSTM, same as a title data.
Next, research result. The following are the part of content that will be discussed: model result and conclusion. The following is the result of final research. The title model with Windows size 3, embedding size 200, and unit 128 produced the best accuracy result in experiment, 79.18, and the content model, the model with Windows size 5, embedding size 100, and unit 256 has the maximum accuracy, 92.80. Next, conclusion research. The following is conclusion of the final research. The first is embedding size. The vector model results are unaffected by the Word2vec embedding size parameter used. The vector that will be input to model is only affected by the embedding size. The second is window size. The classification model performance is affected by the window size 3 and 5. The third is unit LSTM. The classification model LSTM unit parameter have an impact on model performance. In addition, the number of unit in model influence the processing time. Therefore, the greater the unit, the longer the computational time.
In this part, I will describe about the preprocessing implementation, and this is the library that used in this implementation. In this part, we can see the process for the dataset. The first dataset is stored in the F1, and the second dataset is stored in the F2. This is the original form of the F1 and the F2. In this part, we can see the original form of the first dataset that contains URL, headline, body, and label column. And this is for the second dataset that contains ID, title, text, dan label column. Next, the first preprocessing implementation is data reduction. In this part, we can see there is a function that used to reduce the column that is not required in this implementation. This is the result for the first dataset that use ilog function to take the column that is required in this implementation. The result for the first dataset contains headline, body, and label column, and for the second dataset contains title, text, and label column. Next preprocessing step is data cleaning. In this part, we can see there's a function that used to clean the null data. The data cleaning is null function to sum the data null and remove the data null with drop null function. This is the result for the first dataset. This is for the second dataset. And we can see after and before implementation the data cleaning process. Next, data transformation implementation. Data transformation is only implemented for the second dataset. The second dataset has a string label that must be transformed into binary label. Data transformation use map function to transform the label, and this is the result for the second dataset. Next, data integration. In this part, there is a function that you'll use to integrate the dataset. Data integration uses the merge function to integrate the dataset, and in this part there is a process for remove the duplicates data, and this is the result for data integration implementation. Next, construction. This is the process for install the construction because construction is used here. This is the function that used to make a data becomes a unit, and this is used for check the data that has abbreviation inside. The result for the construction preprocessing, we can see here for content, and this is for title. This is the result for construction preprocessing for content. In this part, there is no abbreviation. Same with title, the result has no abbreviation. Next, remove URL. Remove URL use regular expression to remove every non-white space character with domain net, com, org, and etc. And this is the result for content, and this is the result for title. In this part, there is no URL again and title too. Next, punctuation removal. In this part, there are two functions. The first function is looping function that used to check the punctuation from the data, and the second function is remove punctuation that used in this part to check the punctuation and remove punctuation from the data. This is the result for content, and this is the result for title. In this part, there is no punctuation again, and title too.
The next is scaffolding. In this implementation, we using Python function .lower to convert all the news data to lowercase. And this function will be doing to content and title data. This is the output for content, and this is the output for title. Next is tokenization. In this implementation, we built a tokenization function to break sentence into a tokens. And in this implementation, we use a refine all function and this expression, where this expression are matched with alphanumerical character. So this implementation will be check the character by character in the data, and then if it match space, then it considered as a one token. And this implementation will be doing to data content and title data. This is the output for content, and this is the output for title. The next is stop word removal. In this function, we built a function to check every word in the data for filtering from suffix, prefix, article, or conjunction. And then the function will choose the important data from the tokenization data before. And this is the output for content. And this is the output for title. The next is lemmatization. In this implementation, we using a WordNet library, and then we create a looping function to check every word in the data to normalize with Python function .lemmatize. And then if the words are registered on the WordNet, and then the word will be formed into a basic word. And we will be doing this function to content data and title data. This is the output for content, and this is the output for title. And then we save all the data after applying all the pre-processing stage from data reduction until lemmatization. The next is implementation about Word2vec. In this implementation, we using a Word2vec library, and then we build a model to vectorize the news data, and the main parameter will be used is embedding size. This is for the size of dimension to vectorize the news data, and then the workers, and then iter, and then SG, and then min count to count minimum word while training model, and then window size. Window size is space or distance between target and context word. And for the result of vector will be saved in variable word underscore embedding. We can save a result of vectorized data into a Word2vec model. From the result of vectorized data, we can use to search for term vector. In this implementation, we choose to search for computer vector. This is the output, and then we can use the result of vectorized data to search for similarity between two terms. And then in this implementation, we choose to see LSTM similarity. The next, we can visualize the vector using matplotlib and PCA. And then we build two variables. The first is term underscore list to accommodate the word to be visualized, and then the variable term underscore vector to accommodate their vector. And then the vector in variable term underscore vector will be reduction with PCA. And then with matplotlib, we can use the template in matplotlib to visualize the vector. And this is the result. From the result, we can see many clusters based on their vector.
Next, implementation of counting word frequency. In this implementation, we'll get a vocabulary from title or content data by using the update function of the counter library in the package collection. The following is the result of this implementation. Next, implementation convert word to integer. In this implementation, we'll convert the words in the title or content data into integer based on vocabulary ID that has been given previously. The following is the result of this implementation. Next, implementation of matrix vector Word2vec. In this implementation, we'll take the result vector from Word2vec process based on each word obtained from the previous tag. The following is the result of this implementation. Next, implementation of padding sequence. In this implementation, we'll equalize the length of title or content data sequence using a pad sequences function in Keras library. Title data 68 and content data is 1000. The following is the result of this implementation. In this implementation, stratified default function is used to divide the data test and train. On the main model using multiple layer from Keras library, and model will loop 10 times. The first layer is embedding layer, the second layer is dropout, the third layer is bidirectional LSTM, and the last layer is dense layer. To evaluate the model, use accuracy, recall, precision, F1 score, and computational time. Each model will be evaluated using test data. The following is result of this implementation. That's all about final project. We are from TA103 group. Say thank you for your time and your attention.